Hi everyone, welcome back to this channel. Today we're going to do a comparison of about, I think, 7 different languages. First of all, I'll explain the algorithm. So the algorithm is called the traveling salesman algorithm, which is basically a way to find the best route. Now, say you have like 20 locations you want to go to. So you start at 1 and you need to go to 1 and then go to another, go to another. You need to go to all 20 locations and you need to find the shortest route. And there's an algorithm to do this. And it's normally a good way to test performance. Because say, for example, so there's 20 locations, right? So if you add up the total amount of points, it starts with 20, so you have 20 possible starting locations. So it goes, the first one you have 20, and then you have 19, and then you have 18, and then you have 17. So it's basically the total number of these will be 20 by 19 by 18 by 17 by 6, by a very big number. So that's why it's good for performance. So I'll just explain how the algorithm works. So what this uses is a thing called recursion, and recursion is where you call the same function multiple times. So you could do this with loops, but doing it with loops is very ugly in coding, and it's also not very also not very adaptable if you do it with loops. So firstly, we have a multi-dimensional array, which is simply just a way to set the distances. So if you go from point A to point B, that will be in say 0, 1, something like this. So what we need to do is simply pick a location and then from that location pick every other possible location and then go through every point until we get to the final point, and then we need to find the distance. And this we use with recursion. So what we do is we have a recursive function that will simply just loop through every position that we haven't gone through already and simply call the function again. The problem with just doing that, though, means we will infinitely do this and will crash the computer or crash the program. So what you need to do is have some kind of check, because obviously if you just simply look for all the locations and keep going forever, it will. So if level equals the amount of locations, then we need to stop. We do that by returning normally. And then we need to check if that is the best time, or we need to check if that's the lowest distance. So we check if it's the lowest distance, and if it is, then we save it in a global variable, and then we save the route that has been added up together so far as the best route. So doing just that would also be very slow as well. What we also need to do is we need to have some kind of pruning. So what pruning means is we ignore some things that are bad. So what I decided to do was, so we have the minimum distance already, the best distance we found already. It starts at like the max int number, then it will say, for example, so we go through the route, right? And we find, say, 250. Let's say 250 or whatever number you want. So the total route is 250, and then we do it again and look for another route, and we find 260 before the end. Well, we know that that can't be 250, so we should just go back. Just skip this, ignore these. So these are bad, they're going to be higher than that, so don't bother going through them all. So this is a way to reduce the amount. It's called pruning, and if we didn't do this, then it would go to maybe like 10 times the amount of nodes it goes through. So that's it for the algorithm. I'll just put out a disclaimer about this. So computers are fast. If I have to make this a very, very complicated algorithm. If I don't make this a complicated algorithm, then every language here will do this in like 10 milliseconds or less. Maybe 0 milliseconds. It would be in nanoseconds. So you have to make it a lot. I think the total for this is something like 600 million or something like this. I'm not sure exactly how many nodes. It's something like 600 million nodes it goes through, finding the best algorithm. Finding the best route, everyone has to go through 600 million. That's the only way I can get it to actually go for a long time. So in most of the times, in most things you're doing, performance isn't that critical. Only in like really, really strenuous tasks do you actually need it. So apparently I was completely wrong with the amount. The languages actually were 9. I added 2 at the end, I just forgot. So the languages we're going to test are C++, C#, Zig, Rust, Odin, Go, JavaScript, Python, Java. I think that's all of them. I will list if I forgot any there. So here I'll just go through the code. So let's start with the C++ code. So here we have the array of distances. This is just the distances we want to go through. And the number of cities is a constant, like 20, because it's 20. We want to go through 20 locations. So here the recursive function, find shortest path. So the only thing here that's different with C++ is we have current root as a pointer, because you don't want to pass an array to a function in C++. You want to pass a pointer, so you're not copying an array, because we actually pass here. We have an array current root. We don't want to pass the entire array because you're copying 20 integers each time. You want to just pass a pointer, and you're just copying one integer each time, so it saves a lot of memory. All right, so just added some comments. So here we have, if the distance so far can't be the best score, then return. That's basically the pruning. If at the final destination, then return to the starting point. So we need to go back to the starting point and add the distance. And then if the route was the best, then we save the distance and save the route. And then we just return so we don't loop again. And then if it's not at the final destination, so we return here, so we don't need an else. Then if we loop through all the locations. If the location hasn't been searched yet, set it as searched, add this to the current route, add the duration, and then call this function again to loop through the next locations. That's the C++ code. Let me go to the C# code, which is almost the same. C# code, almost the same really. The only thing that's weird about C# is, I think it's the only language I see. I'm not sure. Let me look at the Java code quickly. Yeah, so I believe C#. So for example, other languages they would do this, right? They would do this. But C# is the only one I know that actually does that, which is kind of weird. The C# is my main language, so it's kind of weird that I've got used to that. But anyway, look at the rest of the code. This is the calling the first function. So we have find shortest path. It's basically the same, honestly. The only difference really is we pass an array, and passing an array in C# is different to C++. It doesn't copy an array when you pass it. It simply will pass a reference to it. Other than that, yeah, we have array copy, and the rest is basically the same, honestly. All right, let's look at the Zig code. It's probably the most interesting out of all of this because it's quite unique, Zig. Zig does have quite a few things that make it a lot more strict. So first we have this annoying thing you have to do with arrays. So we have to, with the multi-dimensional array, I don't know why, you have to kind of specify what type it is with all of them, which is kind of tedious, honestly. Kind of tedious. Then also, I'm not sure why, but it kept giving me errors unless I initialized arrays. So I had to declare an array and then initialize every value. And I also did this down here. I initialized every value in an array. It's kind of annoying. Another thing about Zig also, it's kind of annoying to just pass a pointer to, because you can't, in C++, I'll show you in C++, you can pass a pointer and then use the pointer. See here, we have current root. And then down here, where is it? There, current root 0. So you can basically pass a pointer to a function and use it as an array. You can't do this in Zig at all. It won't let you. So instead, what I had to do in Zig was create a create a struct, which basically just holds the current root array and the visited array, and then I just pass a pointer to that struct. And then in the original function, I just create that struct and set all the values, and then just pass it with a at. So we at this root data. And we're atting the root data. And why is it doing that? So we pass a struct basically, and that's the easiest way to do it in Zig, honestly, because otherwise it's just annoying. There's another thing, we have to use usizes, which I believe is the same as Rust. In Rust, you have to use usizes. If you're using an index, you can't use an int as an index for an array. You have to convert it into a usize. So we int cast this into a usize here, and then over here we have to int cast that. Which one? This one here. So here we're adding the root, but the root will be if we do a loop here, the I will be a usize. We have to cast a usize into an i32. But that's basically the only thing that's really different. To get a timer in Zig, we use this stdtime.millitimestamp, which gives you time in milliseconds since 1970. and then we do that again, then just minus them, and that's how you basically the simplest way to make a timer in Zig. All right, now we have the Go code. So the Go code I didn't actually write a single word of. I just threw it at ChatGPT. The main reason is I just don't like Go. It's just not my kind of language, honestly. The main reason I don't like Go is because it's actually done it here. This will be an error in Go, I believe. I should probably edit that, actually. This will actually be an error in Go if I do this. Yeah, I just don't like that, mostly. I hate having the curly braces on the same line. It makes things very hard to read for me, and I like to write semicolons, and you can't do that in Go, so anyway. But the Go code is relatively similar, I believe. Yeah, so looping through, we copy. This is kind of weird syntax in Go. But other than that, yeah, it's relatively similar, honestly. This looks a lot like Odin, actually. Because the Odin code almost looks identical to that, except for the plus plus. That's the only thing that's difficult in the Odin code. Yeah, so that's the Go code. I didn't touch the Go code at all, because, yeah, I just don't like it. The Java, which I haven't written a word in Java, honestly, but because I know C#, apparently I know Java. But I had a kind of annoying problem installing Java, because you have to install like version, like it recommended version 8, but version 8 is for running stuff in Java, and I wouldn't actually make stuff, so you needed version 22. But as soon as I got that fixed, it was alright. But then building Java is also weird. Like, why do I need to make a class? So at first I need to make a class with Java, and then I need to... Java's weird. Anyway, but other than that, it's mostly the same. Trying to see anything here that's kind of interesting that I can talk about. This is... Well, 1 minute. I have to fix this. This is terrible. I was just fixing the indentation that was kind of annoying me. So there's not actually anything to say in Java. I mean, the one thing I found really weird was concatenating strings. I found really annoying, and I just really couldn't be bothered to do it. So I just put the nodes in directly instead of saying nodes equals nodes. I just put nodes. But that's basically it for Java. It's basically the same as C#. I can't see any difference, honestly. All right, now we have JavaScript. Everyone's favorite language. I don't know a word of JavaScript. Again, I just threw it at ChatGPT. Weird thing, I would never like JavaScript, mostly because it's not strictly typed. So, like, you pass current root in. What's current root? Is it an array? Is it a single integer? Apparently you're passing an array, but, you know, it doesn't tell you that. It just tells you current root, which I don't like at all. I like to know if it's an array or not. Other than that, it's pretty fine. One kind of caveat with this, the JavaScript I ran in a website, which could affect performance, but, I mean, you can run the code yourself if you want. I don't know if that will actually affect performance or not, but I mean, normally JavaScript runs on websites anyway. I couldn't be bothered to actually install anything to run JavaScript, so... Alright, next we have Odin, which lots of people haven't even seen a word of Odin code, actually. One thing to know about Odin, it's very similar to Go, actually. So if you want to declare a constant, you use ... colon. If you want to declare just a mutable variable, then it's colon equals. For some reason, it didn't let me do colon for this and let me index it, so I had to make it. Variable for some reason. I don't know why. I'm not really an expert in Odin. Another thing that's kind of weird in Odin is you don't use, similar to Go, I guess. If you look at Go, there's no like for a for loop, for example. The for loop, there's no brackets. There's no curly brackets. Whereas same in Odin, there's no curly brackets for ifs. For if, there's no curly brackets, and for that's an error. How is that got in the final build? I'm guessing I didn't edit that when I should be like this. Yeah, so it shouldn't have curly brackets. I don't know why that had curly brackets. Let me change that. All right, so yeah, you can't have curly brackets in ifs and in for loops. I'm trying to think of anything. Yeah, so to get the timer to work, I wasn't sure how to do it, but apparently you have a stopwatch class in time. So you have a stopwatch, you create it, and then you reference it saying stopwatch start, stopwatch stop, and then that is a way to basically time something. Using printf is a bit like C. So what Odin is basically it's like a way to simplify C and make it better, but with the same performance is basically what Odin is. What's interesting also is the pointer symbol is actually a point, which I find pretty interesting. Also, I created a struct as well. Like in Zig, I created a struct because I just thought it would be easier to pass a reference to a struct than to pass a reference to an array, because I don't think you can use the... Because this is like Odin, Zig, C++ are the only actually manually managed language that you can actually use pointers. Well, you can use pointers in C#, but there's no point in doing that. But anyway, so... Easier just to use a struct and pass a pointer to a struct than it is to pass a reference to two arrays. All right, and then we have Python. So Python is almost the same, really. It just looks a bit weird because the indentation requirements of the language. You do have to use global here because you're using a global variable, which I found a bit weird, honestly. I don't know why you need to use global there, but other than that, it's pretty much the same. We loop through, add the best path, return here. If not, then we loop through. If it's not visited, then we loop through again. This is mostly the same. We have to. I think I had to declare these. I don't know why I had to declare them. I don't want to see that. And yeah, that's pretty much it for the Python code. All right, now we have Rust. Rust, I again didn't write a single word of. I find Rust probably the hardest language in the world to learn, other than maybe Haskell. So I don't want to touch it. It does look actually quite similar to Zig in some ways, but I would way prefer Zig than this. Anyway, so that's why is it declaring array like this? This is this. It takes up so much more space like that. Anyway, I basically just threw this at ChatGPT. But the most hilarious thing about this is, like, the whole point in using Rust is it's supposed to be memory safe, right? You look at this. When we print this, for some reason, it's using unsafe. And then you look at the entire recursive function. It's just wrapped this in one unsafe block. So what unsafe is basically it's a way to just kind of avoid all the memory checking stuff and all the safety in Rust. Which I think, what's the point in using Rust if you're going to use unsafe? Wouldn't you just rather use C++ or an easier language to write in? But anyway, yeah, it just made everything unsafe because I guess it just said, screw the borrow checker, I don't care, I don't want to do this anymore. But if you remove unsafe, it does actually fail. I'm not sure if that's because you need it to be unsafe for this to work. I don't know. I don't understand Rust enough. Also, it's kind of weird how we do this. I guess because the syntax of Rust is very long. So current root at mute brackets I32 dash number of cities. It's like really long. So if you put this on like one line, it would be like ridiculously long, like this. Like you can't read it. I guess that's why it's kind of standard to do this and put them on. I find that weird though, but I guess you can get used to it. Other than that, though, it's very similar. Copy from slice. So apparently the current root's a slice. That's interesting. All right. I don't really understand half of this, to be honest. I can kind of understand it, but it's not like I'm not an expert at all. Why is that let mute? What? Okay, I don't understand, because you're making this mutable, but we're just setting it constantly to this. So why is it immutable? I don't know. I don't really understand Rust well enough to do this. Anyway, so that's the code. Here are the results. Alright, so first off we have C#, which was a bit slower than Java, actually, and just a bit higher than Go. So Go is a bit slower than C#. They're about the same performance, and Java's a bit faster. Python, yeah, I mean, if I put Python to scale, it would be like, basically everything else would be like this, and this would be, like, massive. So Python took, like, 2 minutes, and then JavaScript took, like, 15, 16 seconds. So don't really use Python for anything that you need performance for. Well, same with JavaScript, even though it runs most of the web. Then we have Rust, then we have Odin, then we have Zig, and then we have C++. They're mostly negligible, really. I'm not sure why C++ was faster than Zig. I'm not, maybe because Zig has some error checking or something like this. But I used release fast on all these builds, so of course this isn't like a test that shows every possible situation. There's just one situation. This mostly tests like loops and recursion. It won't test everything. It won't test. I also try to avoid using garbage collection and tried using it and avoided using abstraction. If you use abstraction, it'll be a lot slower. But yeah, this is just one example, and it doesn't show everything, and doesn't mean that you shouldn't use Python, because Python, the whole point of using Python is because it's easy to learn, and you don't need to know much about the things you're using, and there's tons of libraries. So the whole point of Python is not speed of the program. It's easy to use and practical. So just because something's slow doesn't mean you shouldn't use it. Anyway, I've probably talked for too long, so let me know what you think about this test, and see you guys next time.